Hello and welcome to this session on building accessible universal Windows applications. So I was going to give you all kinds of chapter and verse on why you should make your applications accessible, but I think that Stevie Wonder summed it up better than I could at the recent Grammys when he said that we should make every single thing accessible to every single person with a disability. But even if you're convinced, as I am, that making your apps accessible is the right thing to do and that it makes good business and financial sense, what you might be struggling with is how you go about doing that. How hard is it? What's it going to do to your bottom line? As a working developer, these things are important to you. Well, my name's Sean Hayes. I'm an Accessibility Program Manager in the Operating Systems Group at Microsoft. And over the course of the next 30 minutes or so, I'm going to show you that it's not as hard as you might think, and with a few small changes, you can make your apps a fully accessible experience. So what do you need to do in order to make your app accessible to the widest possible audience? Well, it really breaks down into two camps. The first camp is playing nicely with the Windows Automation Framework. Windows ships with a number of inbox accommodations for various disabilities. For example, we have Narrator, which is an accommodation for blindness. We have Magnifier, which is an accommodation for low vision, and we have Windows Speech Recognition, which is an accommodation for mobility issues. Each of these tools relies on the Windows Automation Frameworks to do its job. So the better that your app can work with the Automation Framework, the better it will work with these tools. In addition, the Automation Framework is also helpful for testing your application. And if that's your interest, there's a talk on using the WebDriver interface as a wrapper around the Windows Automation API. And that's some really cool stuff that's happening now. But for the purposes of this application, talk, we're going to be thinking about the Windows Automation from an accessibility point of view. The second class of thing that you need to take into account is respecting the user's settings. Windows has a large number of settings that users can tailor their environment to meet their particular needs. For example, we have settings for color and contrast issues. We have settings to make things bigger, both the default display and also for text sizing. We have settings for slowing things down to allow people a little more time to read transient UI, and also to suppress things like animations, which would be distracting for some people. Okay, and all of these things your app needs to be aware of, and there are two classes in the system, one in the XAML framework called UI settings and accessibility settings. And by paying attention to the settings on these classes, you can tailor your application so that it'll respond to changes in these settings and tailor your interface appropriately. So what we're going to cover today, we're going to look at how you use XAML applications and elements appropriately, making sure that we can help the framework out when it has information that it can't deduce automatically, and we're going to add different properties to help the system out. We're going to cover sending events to the automation system, but also using events appropriately within the XAML framework so that the automation system can hook into that. And then in the last half of the video, we'll cover respecting the settings. Okay, so enough of the slideware. Let's have a look at some code. But before we do that, I'm going to show you this application I've built. It's a kind of dice game, just as an example of the sorts of things that code that I see every day. And this is a game, and up in the top left-hand corner here, it's based around the idea of the craps game, and I can roll the dice, and when I do that, this string in the top right-hand corner changes to reveal the craps name of that roll. And this all seems to be working fine, and with my mouse or with touch, this will work great. So you might be thinking, well, that looks okay, why can't I ship that? Well, we need to think about how our app looks from the perspective of somebody who's blind in using Narrator. And I'm going to turn Narrator on now using the Win-Enter shortcut key.
No previous text. Close build depth. Hard title bar. Hard close build. Restore minimum. Restore close. Hard title system collapsed. Menu item.
Okay,
menu
so
space.
as you can hear, Narrator is reading out the system Chrome here, and it's also reading out the string hard 10, but it's not actually getting to my dice roller button at all. And so from the point of view of somebody who's blind, this application is completely useless. They can't roll the dice, they can't read what the dice is saying. So we'll have to look at the code and actually see what's going on here. So I'm going to quit out of
Exiting narrator.
Quit out of this, and let's go and look at the code and see what's actually going on here. Okay, so you can see that in this application what we have is a stack panel which actually contains two font icon elements. Each of these font icon elements is using a Unicode glyph to represent their dice, and they're stacked together. And the way that I've taped this so that it's actually working is I have a tapped handle on the stack panel. Now, in order to understand the problem here, we have to step back slightly and think about how a screen reader actually reads the screen. Now, as a XAML developer, you'll be familiar with the idea of a UI tree, which is representing all of the elements on your screen. Well, the automation system maintains another data structure, which is very similar, and that's used in order to present a uniform interface between all of our different frameworks, whether it be XAML or the web platform, Edge and IE, or the common controls in Win32. And the way that the information is brokered between those two things, there's some elements in between which kind of convert information from the UI tree and then present it on the automation tree and back vice versa, and those are called automation peers. Now that translation system is generally speaking automatic, but it can only work its magic if it understands the way that you're using the elements. And in particular here, it's not expecting a stack panel to be an interactive element. And so it's not actually translating that into anything in the automation tree. But if we think about the behavior of what this stack panel is actually doing, it's actually much more like the XAML element which is specifically designed for that kind of interaction, which is the button type. And because the button can have any kind of content within it, what we should be doing here is actually putting this stack panel inside of a button, and so that we'd actually get the correct semantic behavior, and then the automation framework would know what to do with it. So I'm going to go ahead and do that. I'm going to wrap this element up into a button. And then what I'm going to do is I'm going to actually move these properties actually up onto the button itself. Okay, so now when I run the application, and we'll start narrator.
Build demo window button. Caps system collapse minimize button. Cap system restore close button. No next item. System fever button. Caps lock. Caps fever
Okay.
5.
So now you can hear that the button is actually
Fever
showing up
button.
in the automation tree, and I can reach it with narrator.
Fever 5.
But it's actually just announcing it as button, and that's maybe not so much of a problem in this application where we only have one button, but in any real application where we have tens or even hundreds of buttons, it's not going to be very useful to me to just hear button, 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 without knowing what that button actually does. And so in this particular instance, we need to fix that because we need to help the automation system out to know what to announce when this button turns up.
Exiting narrator.
So we're going to look again at the code and see what's happening. Okay, so this button actually, as I said, it's going to contain this stack panel of information, but if we look in there, there's really no string that the automation system can promote to be the name to announce for this element. So what I'm going to do is I'm going to help the automation system out by adding a property here, a name property in the automation namespace, and I'm going to call it dice roller. So that now when the narrator reads that out, it's actually going to have something useful to say. But the other thing that is also important here is that, well, although when I have focus on it, it'll read the button, when I click the button, I'm not going to hear anything about the string that's changing, because that string is not where the button has focus. It's elsewhere in my UI. And whenever you have this pattern of something changing that's not where the screen reader has its area of focus, the user's not going to know that anything has happened unless we tell them. And so there is a way that we can tell them that something's happened by sending something called a live region event. And so I'm going to uncomment this, this accessibility helper function here. And what's actually going on that is in here. So we can see that, if you recall, I said that there's this brokering object called an automation peer. Well, they all inherit from this class framework element automation peer. And there's a couple of static classes on that class, one of which is a listener exists method, which you can ask, is anybody actually listening out for this event? And if they are, then what we do is we'll ask for the actual peer for the element that has changed, which in this case is the stickman, which is the string calling out the name. We're going to create an automation peer for that element. And then when we have that automation peer, we're actually going to raise an automation event on that element. And in this case, we're going to use something called a live region changed event. And that'll send something to the automation system, and it will then know that something's changed on that string. But then there's another part to that, because we also have to actually respond to that. And in order to do that, I need to add something to the string itself, which is an automation properties.live setting. And as you can see, there are actually three options here. There's assertive, which will say, please interrupt immediately and read out the change, which is something that's fairly aggressive, and we don't recommend that you use that very often. Off, which is the default, which will happen so that nothing will get read out. And then the one that you will need in this case, which is called polite, which means that when the screen reader has nothing else useful to say to the user, then it'll read out the change. And so now when I run this application, I can start narrator again.
Build demo window. Build demo window. 7 out. Fever 5.
Okay, so you can see here that it's reading it out, but actually I'm using my pointer here, but most screen reader users and a large class of other users don't actually use touch or the mouse to drive the application. They're expecting to use the application through the keyboard. Now if I try to tab around in this application, I find that I can't actually get to the thing that I need to get to here.
Item has no secondary item has no primary action. Tab. Item has no primary action.
You can hear that. So a large class of users that use screen readers or even have certain ability issues will expect to drive their application through the keyboard. Now if I'm trying to drive this application, drive this application through the keyboard, you can hear that
no primary action.
Nothing's actually happening on the dice roll, even though I can click it
7 out.
with the mouse. If I try to drive that
item has no primary action
with the keyboard, nothing's happening. So why is that? Well, we'll return to the code.
Exiting narrator.
Okay, so you can see here that when I copied those properties off of the stack panel, I actually copied this tapped handler, which is what was making the stack panel interactive. And that will work on a button, obviously with the mouse, but it's not actually the expected primary action for a button. The primary action for a button is clicked. Each of the XAML elements has a primary action which is hooked up to the automation system. For example, a toggle button will be hooked up through the checked and unchecked handlers. Now here, what I should have used is a click handler. So let's go ahead and replace this with a click handler. And now when I run it, the application is going to work fine. Okay, so now the keyboard is responding, but I seem to...
Hard 10, hard 10, hard 10, easy 6, hard 10, easy 6, 7 out, 9er.
Okay, so now we're reasonably assured that our application is presenting itself appropriately through the automation API. And there's actually a tool in the Windows SDK called Inspect, which you can use to actually look through all of the automation properties in your application and make sure that you have accessible names in the right places and that all the right things are in place so that the automation system will work well. Okay, so let's assume that we've covered the base now for the automation system. What happens now if we look at the user settings? What I'm going to do next is I'm going to actually put my computer into the high contrast mode, which is an accommodation that will people with low vision who have contrast issues. And I'm going to choose the high contrast black theme, although we can't be sure in the contrast theme what these actual colors are because the users can tailor them to their own choices. And let's see what happens now. Okay, well you can see that the rest of my UI has gone into the high contrast theme, but if I look at my application, the only thing that's actually changed is this text here, which has picked up one of the high contrast colors, but nothing else in my application has changed at all. In fact, the opacity in the color here is really actually making the contrast worse, if not rather than better. So what's going on in here and how can we fix this? Let's get out of the high contrast for the purposes of the video. And have a look at what's going on in the code. Okay, well the first red flag is this background here where I've hard-coded the Alice blue color. When we go into the high contrast theme is unable to change this hard-coded color, but you saw that it did actually change here, this foreground, where I'd used a theme resource. So obviously the trick here is to replace this background with a theme resource. So let's go ahead and do that. And I'm going to use this theme resource of a dice background. But what does that dice background actually map to? Well, let's have a look in the app.xaml, where I have some resource dictionaries set up for the different color themes that I could be in. And in here I have a resource dictionary which would work under the high contrast. So let me just uncomment that. So when the high contrast is in action, this key will activate this resource dictionary. And in here you can see I've mapped that dice foreground and dice background pair to two colors which I know are going to map to two antagonistic colors in that high contrast setting. So now I'll get a decent color response in my application. And that's great, but there were other issues here. For example, there's this opacity, and also we have an image brush which is filling out the picture of that game. So we really need to turn those off as well. And the automatic system isn't going to do that for us. But to change that, I'm actually taking advantage of a relatively recent change in the XAML frameworks, which is something called a custom visual state trigger. And if I comment this out and explain what's going on there, this visual state will happen when my system goes into high contrast. And if it does, these setters will apply an opacity of 1 to the dice and also get rid of that main theme background by setting it to just a theme resource, which is a plain color brush. Okay, so I'm going to run the application now and see how it behaves in the high contrast mode. Okay, so let's turn on high contrast. Okay, and now we can see that the application is much more usable. I'm getting good contrast between the background and the dice values, and everything's working out fine. Now obviously in a real application you might actually use some assets which would behave better under a high contrast mode, but for the purposes of this application, for the demo, this is fine. Okay, so that's covered just the high contrast setting, but in fact actually most of the settings work in much the same way. So as long as you're aware of those two classes, accessibility settings and UI settings and the various values on there, you can use things like triggers and so on to tailor your application appropriately. Okay. All right, let's return back to the slides now. So in summary, if you recall, we had these things called automation providers or automation peers. And actually a large amount of the work was being done for us in the framework. The framework was able to take responsibility for most of the things that we need from an accessibility point of view. But we did still have some responsibility in our to work well with the automation framework. For example, we have to make sure that we're using the right semantic constructs for the things that we're doing. So, you know, something's interactive, it should be a button that's clickable, invocable. If it's selectable, then we should be using a list view or a grid view and things like that. We need to make sure that the markup is ordered correctly so that there's a good linearization as we're tabbing through or arrowing through with narrator. So we're revisiting things in the correct order. We need to provide information that the framework can't deduce automatically. For example, we had to put in an automation name so that there was something for the narrator to read out when we got to that element. We need to use some events. We were sending events to the automation framework in order to tell it that things had happened that it might not otherwise have announced. And also we needed to make sure that we're using the right semantic events on our elements, like using the click handler on the button and so on. And then lastly, we looked at respecting the changes in UI settings and the accessibility settings classes based on a handler so that we were able to pick that up. Now I didn't show you the custom trigger, but this code will be available within the download which is accompanying this video, so you can look at that at your leisure. So with that, here's some more resources that you can have a look at. As I mentioned, the inspect tool, that's in the Windows kit, so you can find that out. You should definitely check out the session on WebDriver testing, use the automation framework. You can look at our enable site where we have lots more information on how to make your applications accessible. And also on the Microsoft Virtual Academy, there's lots more information. And also a shout out to the thank you for providing the CRAPS layout image. Okay, so I hope that that's given you an intro to making your application accessible, and I hope that one day Stevie Wonder does drop by and is duly impressed by the accessibility of your application. Thank you and good night.